Hi guys, welcome back to the channel. In this video we are going to discuss the implementation of higher decoders with the lower decoders. So this is also a combinational circuit because this is the decoders. So let's get started. So these are the three basic things that we want to know. So in the previous video we already discussed the basic decoders, that those are these three. So 2 to 4 decoder, 3 to 8 decoder and 4 to 16 decoder. So in this video we are going to convert from 2 cross 2 using 2 cross 4 decoders to convert 3 cross 8 decoder, and from 3 to 4 to 16. So these things we will go into see. In a simple manner that I can say, these are the three conversions that we are going to perform in this video. So let's start with the 2 cross 4 decoder to 3 cross 8 decoder. We are going to implement 3 cross 8 decoder with the help of two 2 cross 4 decoders. So if you observe 2 cross 4 decoder, each have the 4 outputs. So 4 plus 4, 8 outputs. So that is only our required thing. So in the 3 cross 8 decoder we have 8 outputs. If you are taking 2 cross 4 decoders also, we are going to have 8 outputs, but we need to connect the inputs. So let's see how to connect the inputs so that we are going to interchangeably use as 3 cross 8 decoder. For this implementation of 3 cross 8 decoder with the help of 2 cross 4 decoders, so you are going to have the same inputs. So that is AB for the 2 decoders, and you are going to have the third input for the 3 cross 8 decoder. So we already know for the 3 cross 8 decoder we need to have 3 inputs, that is AB, and the third input is E only, E itself. So if you are passing E as 0, so if you observe that is 0 for the first 4 terms and 1 for the next 4 terms, that you can observe that is very simple, I think. Because suppose if you observe, if you have AB as 0 0, so enable is also 0, then you are going to select the D naught. If enable is 0 only, now you are going to change the AB as 0 1. As enable is 0, so you are going to write EAB, so 0 0 1, that is D1. So next you are going to change AB as 1 0, so we are going to represent that output as EAB, so 0 1 0, so that is 2 D2. So if AB is 1 1, so E is 0 0 1 1, that is 3, that is D3 will be selected automatically. If enable is 1, then you are going to select the second one, that is E bar. Then you are going to see that is suppose if AB is 0 0, then you are going to E bar means that is 1 0 0, that is D4. Likewise you can obtain any sum. If you want the seventh one, that is E bar is equals to 1, then suppose AB is 1 1, so that is E bar AB, so the output would be 1 1 1, that is E bar AB D7. I hope you are understanding this. So final statement that we can say or pass is this circuit is equivalent to 3 cross 8 decoder. So the implementation is like this. We have to perform the implementation like this. So we can implement 3 cross 8 decoder with 2 cross 4 decoders. So if you see the truth table, it becomes more clarified. So if you observe the truth table, you can see that is the EAB. So we are going to represent in any fashion, but we are going to represent here as EAB. So we are going to have 8 output terms, that is D0 to D7. So the truth table will be same. The diagonal elements will be 1, all the selected lines according to the input lines. Next conversion that we are going to see is 2 cross 4 decoder to 4 cross 16 decoder, means the implementation of 4 cross 16 decoder with the help of 5 2 cross 4 decoders. So let's see how to perform with the 4 cross 16 decoder with the help of 5 2 cross 4 decoders. So I am taking here 4, so let's convert to that. So this is the representation of 4 cross 16 decoder using 2 cross, means not 2 here we are going to use 5 2 cross 4 decoders. So why we need 5 decoders? So let's understand why we need that. But the connections are like this. So if you observe the first decoder, you are going to pass I1 I2 and obtain outputs as Y0 Y1 Y2 Y3. So you are going to pass these 4 outputs to the 4 decoders as enable inputs, and output you are going to obtain final outputs from D0 to D15. So the inputs for each decoder you are going to pass as I3 I4. You are going to see that, observe clearly, all the decoders have the same inputs, that is I3 I4 in the same order. So I think you have some doubt. So how that previous circuit is obtained and how we need to recognize or is this circuit is true or not. So we are going to check with some examples. So I am going to put I1, I2, I3, I4 with these examples, and I am going to check I am obtaining the D1 means the D expressions or not. So let's get started with the first one, that is 1, that is 0001. We are getting D1 or not. Let's check. The first example that we are going to check the circuit diagram is true or not, that we have implemented the 4x16 decoder with the help of 5 2x4 decoders. So we are going to have that I1, I2 in the first decoder, that is 00, we are passing that, and we are going to pass 01, I3, I4 for all 4 decoders as seen there. So if you observe, so as this is the first decoder is 00, we are going to select Y0. You can see the highlighted line also, what is orange line. Then enable line E selected, means the single decoder is selected. So in that single decoder also we are going to pass, that is 01. 01 means D1 line is selected. So this is correct, D1 line is selected. So we are going to pass 0001. So D1 line is selected, it is true. The next example that we are going to see is, that is 0111, that is we want to get that D7, or we know that is D7. So that is 01, I1, I2. So I1, I2 has to be passed in the first decoder. So after passing that, 01 means what? That is we are going to select Y1 because that is 1. So Y1 means the second decoder will be selected. The second decoder, next I3, I4 is what? 11. 11 means what? The last term, the D7 will be selected for the second decoder. Remaining 3 decoders will be intact because enable line is 0 for the remaining 3. I already said when enable is 0, it will not work. Enable is 1 only, it will work. Enable is 1 for the second decoder only. So in the second decoder, we are passing 1, 1. So output would be 1, 1, D7. That is the fourth term. The similar way, we are in this is the third example, that is 1010. We know that is in decimal is 10 and D10 that is. So if you observe, that is 10. 10 means 2. So we are going to select the third line, that is Y2. So the third line is corresponding to enable line, that is third decoder. So we are also passing, that is I3, I4 as 10. 10 means the third term only, that is 10. So I hope you know how I am using the 2x4 decoders to manipulate the outputs. So finally D10 is the required one, is selected the same only. Hope you are understanding. So this is the last example, so that your understanding will be much more in this conversion. So that is, we are going to take 1110. So that is D14 we have no. So 11, that is I1, I2 we are going to pass for the first decoder, and the second decoder, that is 10, we are going to pass. So if you observe, 11 means the fourth line will be selected, that is Y3. So fourth line means fourth decoder has to be selected. So fourth decoder is successfully selected. So in the fourth decoder, the inputs are 10. 10 means 2. So 2 means what? The third line, D0, D1, D2, like that only we will take. So the third means, that is D14 will be selected. So that is the required thing that we are waiting for. So I hope you understood this conversion. Hence we can say 4x16 decoder is implemented with the help of 5 2x4 decoders, and we already used the variables, that is from I1, I2, I3, I4. So this is a truth table that I have made in. So this is the truth table for 4x16 decoder. You can observe there I have took the inputs as I1, I2, I3, I4. Remaining all the things will be same. The outputs would be the diagonal one, and the enable line is also shown there. That is enable on 1 only, then only the output will be produced, otherwise the output would be 0. The last and final implementation in this video is that we are going to implement, that is 4x16 decoder with the help of 2 3x8 decoders. So if you take 2 3x8 decoders, if you observe in the first one, we are going to have 8 output terms. In the second one also we are going to have 8 output terms. So 8 plus 8 is 16. So we can implement these things, we can add these things, because we have 8 means 8 plus 8 16 output terms. So we are going to see that how we have to cascade these two to get the 4x16 decoder. Let's see that. So this is the circuit diagram that we have to cascade both of the 3x8 decoders to get the final output as 4x16 decoders output. So if you consider that A, B, C as 3 same inputs, and the outputs would be from D0 to D15, means total 16 terms or 16 output terms, we can simply say. So the fourth term or fourth variable is E. So we are going to have the variable as E, A, B, C. That is E, A, B, C, 4 variables. So for the first decoder, that is E is 0. The second decoder E is E bar, that is 1. If you pass 0 as E as 0, I hope you are understanding. You can relate this with the first one, that is 2 cross 4 to 3 cross 8, that you can compare with. You can simply merge the variables A, B, C like that, and the enable is the fourth variable, so you can equate both of them. You can simply say that is the 4 cross 16 decoder is implemented with the help of two 3 cross 8 decoders. Again, this is the truth table for the 4 cross 16 decoder. You can observe that I have represented as EABC. This represents, or this means, for the first 8 terms. Total we have 16 terms. For the first 4 terms we are going to have E as 0. For the next 8 terms we are going to have E as 1. So that is why I am representing the first E, EABC like that I am representing. Remaining all things will be unchanged. You understood the conversions, so this can be used for the implementation of more higher things also. That is 5 cross 32 decoder can be implemented with the 2 cross 4 decoders, or we can implement with the 4 cross 16 decoders also. We can implement 5 cross 32 decoder. So likewise we can have further higher decoders also, but these three are the main 3 conversions that I can say. So I hope you understood. Thanks for watching up to now.